Recall that everything that we've been studying so far this semester helps us understand how we humans surmount the potential obstacles that stand in our way to efficient linguistic communication. To a first approximation, we're incredibly good at understanding each other. For the most part, I'm able to package my thoughts into words and send them to you via speech signals or via written scribbles, and you're able to recover something very close to the meaning that I intended. But there are a lot of ways that this could go wrong, and you've seen various cases of this over the course of the semester. Most language is ambiguous. For example, the women discussed the dogs on the beach has two interpretations. Those derive from syntactic ambiguity. On the beach might be modifying dogs, or it might be modifying disgust. We understand how to describe that in structural terms, and we've seen how people can recruit information to try to disambiguate effectively. And we're quite good at disambiguation. Environmental noise. Most of the time, we are listening or reading in an environment that challenges our attention, where there may be multiple people talking at once. Nevertheless, we're very good. We may miss parts of what we hear, parts of what we're listening to, because there was an intervening sound. But we're good at reconstructing what was intended to be said, despite the imperfection of the perceptual input. Memory limitations also stand in the way of language understanding. Our memory is limited, and that creates a constrained channel in which communication has to occur. And we have incomplete knowledge of our interlocutors. This is actually a constituent feature of communication, a constitutive feature. That is, that if I knew everything about you and you knew everything about me, then you could predict what I would say, and I wouldn't need to say it, and we could just do away with communication and language altogether. But of course, that's not the case. We don't know everything about each other, and so it's useful for us to transmit signals to each other. Of course, we also have to know a little bit about each other. Minimally, we have to share conventions by which we package thoughts into meanings and then unpackage them again. So incomplete knowledge is a constitutive feature of communication, but it also is a challenge. So how do we surmount these challenges? So remember that during the course of the semester, we've been framing the hypothesis formulation and testing approach iteratively as the process of rational analysis. And just to review, there's a background assumption in rational analysis that cognitive agents like human language producers and comprehenders are optimized via evolution and learning to solve everyday tasks effectively. Language is very important for using successfully in order to succeed in our daily environment as social creatures. And so we're probably very highly optimized for it. And we're recruiting resources that have developed in our as parts of our minds and brains over the course of millions, billions of years of evolutionary history, but also we're able, part of this is what we learn over the course of our lifetimes. And so this optimization is a crucial starting point for building hypotheses about how something like language understanding works. Given this background assumption, we can formulate rational analysis in the following way. First, so this is the hypothesis generating system. Specify precisely the goals of the cognitive system. For example, language understanding, the goal is to recover something very close to what the speaker intends to mean, and to have it available for that intended meaning, to have it available for use by the agent. Formalize a model of the environment that the agent is adapted to. This includes the characteristics of the language, the characteristics of the communicative channel, like the noise characteristics of a spoken language environment, and also the fine-grained, detailed environmental statistics, like what structures are frequent, what structures are infrequent, what words tend to be used in what context. Make minimal assumptions regarding computational limitations. Of course, we know that we're computationally bounded organisms, but there are many ways in which our computational bounding might be best characterized, and we're still trying to achieve a good, deep scientific understanding of these characteristics and limitations of the mind. So a working null hypothesis is that whatever the language comprehension system needs to do, it's doing it very well. So whatever limitations may exist that are relevant to that processing for the brain, many of them, the brain, through, once again, evolution and learning, may have become good enough to overcome those limitations as well as is necessary for the approximations that are of interest for us. We'll potentially revisit this assumption later on when necessary, but we'll start with that minimal assumption. Given 1 through 3, we derive predicted optimal behavior. Given the goals of the system, the modeling environment, the assumptions, minimal assumptions regarding computational limitations, we ask, what would the best possible model system do? And then once we have that predicted optimal behavior, we then compare it with empirical data. And the empirical data depends on the domain, the kind of model that we're developing, the kinds of data that we have access to, and so forth. And if we have a good fit, then we've succeeded. We have a model that so far is satisfactory, and we have a good theory. But it may not be the case that our predictions with empirical data are a great fit. There may be discrepancies. And in that situation, we may need to revise, and we will revisit steps 1 through 3. Based on their changes, we will probably need to predict different optimal behavior patterns, and then we compare those predictions with empirical data. And we do that over and over again, and as we're doing that, the idea is that we will continue to refine our theories. In the context of language comprehension, this idea of rational analysis led to a picture so far that looks like follows. We understood that online language comprehension is hard, but there are lots of information sources that can be usefully brought to bear to help with the task. That includes things like the grammatical structure of the language, the fine-grained distributional statistics of words and structures in everyday use, meaning, everyday knowledge about the world, common sense that helps us understand things about the kinds of meanings that an individual is likely to convey. Also, understandings about what a cooperative agent is like, and that's going to play a role as we continue on later in the semester in particular. Given the combination of this difficulty, intrinsic difficulty of online language understanding, with the availability of many information sources that can be usefully brought to bear to help with understanding, then a good picture in the context of rational analysis is that we should be using all information sources available whenever possible. By assumption, we have those information sources. That's the environment that the agent is in. Those information sources are in the environment. And on the assumption of minimal computational limitations, there's no reason we shouldn't be deploying all those information sources because they may be helpful. And so that's a rational view of language understanding. And one particular consequence of this view is that language processing should be highly incremental. We shouldn't have to wait until we've ended a sentence or ended a whole paragraph of text before starting to understand it. So processing should be highly incremental if we're not limited in otherwise in other respects. And we actually have lots of evidence we've seen over the course of the semester that people are doing this incremental language understanding and integration very rapidly, often ubiquitously. And open questions involve how these information sources are reconciled, and the rational analysis will give us differing possible hypotheses. But we've already seen many test cases of this. So a simple example that you saw earlier in the semester is, for example, a sentence as simple as "put the apple on the towel in the box" might wind up being interpreted in rather different ways incrementally, in particular at the time of reading "on the towel," which is temporarily, locally ambiguous between an interpretation of modifying apple, where it's saying where the apple is right now before it gets moved, or modifying put, where it would be describing where the apple is supposed to go. And in scene 1 on the left, where there's only one apple and there's an empty box and an empty towel, on the towel is a very natural interpretation of being a modifier for put when you first hear it, because put needs a location phrase and on the towel offers it. But in contrast, in visual scene 2, there are two different apples, and a natural interpretation on the basis of the scene, distributional statistics of language, the structure of the grammar, and what a cooperative agent would be like, is to interpret on the towel as saying which of the two apples should be moved somewhere. And those differences in the visual context take the same sentence and lead to differing eye movement patterns. And those can be explicated once again under this rational, highly incremental interpretation.